Thank you for watching this DPL tutorial video series. In this series of 6 videos, I will show you the steps to creating a probabilistic Excel spreadsheet linked decision model in DPL Professional. In this video, I'll be adding a decision to the model to determine what the optimal strategy is regarding whether or not to develop this new product. A DPL decision node has 2 or more alternatives. DPL will choose the alternative that maximizes, or minimizes if appropriate, the specified output of the model. For example's sake, I'm going to add the decision node locally and then link it to a cell in the spreadsheet via the Links tab of the Node Definition dialog. To add a local decision node to the model, I'll click the Add Node Split button on the Influence Diagram tab. My cursor moves down to the Influence Diagram pane and has a semi-transparent node beneath it. I'll single-click in the area to the left of the other nodes in the model to place it. The General tab of the Node Definition dialog appears. I'll name the new decision node to be Develop, and we'll leave the alternatives as the defaults, yes and no. On the Data tab, I'll enter the flag values of 1 and 0 for the yes and no alternatives respectively. The flag values match decision switches included within the logic of the spreadsheet. Lastly, on the Links tab, we will connect this node to the spreadsheet by selecting the Microsoft Excel Radio button under the Calculation Links section. DPL assumes you'd like to link it to the same Excel workbook as the other nodes in the model, which is correct. I'll choose the specific cell to link to by clicking the Range Names button, highlighting Develop from the list, and clicking Select. I'll click OK to close the Node Definition dialog, and then we'll use the From Formulas command to generate an arc from the Develop decision to MPV. DPL continues to add events to the default decision tree as I model in the influence diagram. I'll switch over to the decision tree to confirm this. I can see that DPL has placed the decision at the head of the tree. Now that I have a decision in the model, I can run a decision analysis and look at the fundamental outputs, which are the policy tree and risk profile. These outputs provide an understanding of what the optimal decision alternative is and the range of outcomes given that the optimal decision policy is followed. To run an analysis, I'll navigate to the Home tab and look at the Run group where there are several options to consider prior to starting a run. I'm going to check the risk profile and policy tree boxes. I'm going to uncheck initial decision alternatives for now. To start the analysis and generate the output selected, I'll click the top part of the Decision Analysis button. Fast Sequence Evaluation is the default evaluation type indicated, which is fine for my purposes. I receive a prompt that tells me I'm using default probabilities that haven't been reviewed for some of the chance nodes in the model. If you recall, I changed 4 of the nodes at once and did not review their node data. I'm confident that the node data is correct, so I'll click Yes to continue with the analysis. DPL runs an analysis on the model and generates the outputs. Initially, the policy tree is displayed. The policy tree is a complete unfiltered output tree that displays information about the results of the decision analysis. It displays the optimal decision policy and expected values at each point in the tree. Nodes in the policy tree are displayed using the same symbols as those in the decision tree. The 11.6 in square brackets to the left of the decision is the overall expected value of the model. The bolded line under the yes alternative of the develop decision indicates that developing the product is indeed the best alternative. In other words, developing the project is worth 11.6 million, whereas not developing, in this case spending nothing and gaining nothing, is worth 0. I'll use the commands on the Policy Ribbon tab to expand the tree out and see expected values at other points in the tree. Looking one level deeper for the yes outcome, I can see that if launch costs are low, NPV is 18.7, versus if they're high, expected NPV is 2.2. If I were to fully expand the policy tree, I would find that it displays the expected value for all 486 paths or scenarios in the model. When DPL generates outputs from an analysis, it creates 1 or more items for it within the Workspace Manager beneath its parent model. For risk profiles, 2 items are created, one for the underlying risk profile data and one for the risk profile chart. This is due to the fact that multiple risk profile data sets can be viewed within a single risk profile chart for comparison. Now I'll double-click the risk profile chart item in the Workspace Manager to view it. The risk profile is a cumulative probability curve, or S-curve. A cumulative curve displays the probability on the y-axis that the objective function, which is MPV in this example, is less than or equal to the value on the x-axis. The risk profile gives you an understanding of the range of outcomes in the model, given the optimal policy is followed. In this case, MPV ranges from approximately -50 million to 130 million. A risk profile also helps you understand the risk inherent in the project or business plan you're evaluating. For example, if I draw a vertical line up from 0 to the curve and then a horizontal line over to the y-axis, I can determine the probability of losing money, which in this case is about 42%. I can also read percentiles from the curve. So if I wanted to know what is the value such that there's a 10% chance that NPV is less than it, called the 10th percentile, I draw a horizontal line over from the 10% to the curve, then a vertical line down to the horizontal axis. In this case, the 10th percentile is approximately negative 23 million. Previously, we generated a value tornado for the model to see which factors have the greatest impact on value. We call these variables value sensitive. With a decision in the model, I can now run a base case tornado to determine which variables in the model are decision sensitive. I'll return to my model, and on the Home tab, I'll drop down the Tornadoes button, and we'll select Base Case from the list. To generate a base case tornado, DPL sets all of the discrete chance nodes in the model to their nominal state and evaluates the model. Then one at a time it varies each discrete chance node from a low to a high setting, evaluating the model each time in order to calculate the impact of the uncertain variable on overall value. The base case tornado setup dialog allows you to specify which state should be used for each of the low, middle, and high settings. For this model, I'll click OK for the defaults. DPL runs the tornado and shows that all 5 variables are decision sensitive. The change in color of the bar for a variable indicates that the optimal decision alternative has changed when the variable is in its low or high outcome. Blue indicates a change occurring for the low outcome, and magenta indicates a change occurring for the high outcome. For example, when market size is low, the optimal alternative is to not develop the project. Similarly for market share and gross margin. Conversely, if launch costs or marketing costs are high, the optimal policy is also to not develop. I'll now return to my model and we'll save it. This is the conclusion of the 4th video. You can click the information link indicated by the eye in the top right corner of this video pane to request a free 21-day trial license of DPL 9 Professional. A link to the Broadsword Pro Excel file is available on the trial download page. Feel free to work through the tutorials as you watch. In the next video, I will be adding conditioning to the model, and we'll run an analysis to see how the results change.